All right, before you get started welding, you need to make sure you've got really, really awesome near vision. A lot of people who wear glasses to see at distance have trouble seeing up close, and I'm one of them. You should be able to read the equivalent of a 5-point Times New Roman font at about 12 inches. If you're not sure about your near vision, the next time you're at your local grocery store or pharmacy where they sell those uh, over the counter reading glasses, grab a package off a shelf nearby, something that's got really tiny ingredients printed on the back. A Coke or a Pepsi can will do it. And if you can't read that text crystal clear from about a foot away, then you need to take a set of those reading glasses with the lowest magnification and keep checking until you can read that. Once you have the lowest magnification that will allow you to read that small print crystal clear from a foot away, then you need to make a note of what the number is, +2, +1.5, whatever the power is, and you can go on Amazon or to your local welding shop and you can buy a welding magnifier lens, sometimes called a cheater lens. And that will fit inside your welding hood, behind your lens, and it will provide that correction. So you can have your prescription glasses on still, or if you don't wear glasses, then you can just buy a set of cheap reading glasses. But you'll find the magnifier lens is a little bit easier to use. Okay, if you can't see, you can't weld, and you might not know that your near vision is bad until you take the time to check it out. All right, thank you. All right, good afternoon. We're going to take a look today at some stick welding. I haven't done anything really on stick welding except for a video that I did early on the flat AWS D1.1 limited thickness test, which was filmed with my cell phone. So hopefully I'm going to get some better art shots today. I will note that I'm welding today with a small little welder. This is actually a little machine I got off Amazon. It's a Deco little machine. It was 135 bucks. It runs on 120 volts or 220. There's an included adapter to convert it down to 120 volts. And it's a decent little machine. You can find reviews of these online. I'm not going to really go into it, but suffice it to say it runs great. I was running horizontals at 120 yesterday, vertical up at between 108 and 110. It's got a little digital readout on it. It comes with, I don't know, 8 or 10 feet of lead, all number 4 lines. The ground clamp is, decent for the amperage it is designed for. And the electrode holder, it's kind of cheesy, but it's better than some others I've seen. I had a little Zenny machine a couple years ago, and it ran smooth, and this machine runs wicked smooth. I'd actually like to do a blind test myself, by changing out the electrode holder to the same style I use in the school, and really run this side by someone, passing me in the electrode holder, at random between a Miller XMT and the machine I have here. And I don't really know that I'd see much difference. So I just want to note that for stick welding, a couple of things really before I get into the booth. First of all, you've got to have your personal protective equipment. You need to have good gloves. Stick welding can get pretty hot. You're going to need, some sort of a sleeve protection. I'm just going to wear a green shop coat. Leathers certainly would be appropriate. You want to make sure that you've got, your welding hood, shade 10, absolute minimum. I'm running an 11 right now in my hood. And ear protection, you should wear when you're welding. Eye protection under the hood. The hood is face protection, it's not eye protection, so keep that in mind. You're gonna need a chip and hammer, you're gonna need a wire brush, right? You shouldn't really need much else other than that. You can go ahead and pick up a little machine like this if you want to learn on your own. Get some tips from, online sources like here, Weld.com, weldingtipsandtricks.com. There's 100 sources out there that are awesome. And you really could probably teach yourself the basics. At some point in time, you're going to need some more advanced training. And what I'm going to cover here are the things that are the most common errors that I see my students make. And then, of course, how to do things correctly. An instructor can watch what you're doing as opposed to the person in the booth next to you, and they can take corrective action appropriately. I can't cover every single scenario here because no one would watch the video. So get comfortable. You want to be propped up. You want to be leaned on something. Normally I would, put my back into the booth, and if I kind of angle the camera back here a little bit further, and I recognize I've got a lot of stuff in the way, but I would literally lean into the booth, get my elbow on the bench if I have to. My camera is attached to my armrest that's in my booth. But you want to get comfortable. You don't want to lock yourself out, right? You don't want to create such a tight, rigid triangle that you can't move. So you want to do a dry run. And I usually try to avoid getting my thumb. Let me grab my electrode holder. If I'm holding my electrode holder or my MIG gun, I try to avoid getting my thumb over it, because what happens is my elbow, kind of, if you imagine the corner of the screen here as being a rigid stop, my elbow will get locked in and I can't physically push any closer. But if I put my hand on the back side and my elbow hits a point where I'm kind of leaning on it, I can still travel in by simply rolling my hands, okay? I can do that from the underside as well, okay? I can travel. So I tend to do the driving with my right hand because I'm right-handed. So if it's a MIG gun, I'm holding that in my right hand. If it's a stick electrode, I usually just kind of get the back side of the clamp over my knuckles. I'm not really holding it per se. I want to be loose. But then my other hands, it's just fingertips on my knuckles. You want to see where you're going, not where you've been, is a general rule that I would say with stick. But if you're welding horizontals with stick electrode and you need to drag that rod. So here's a stick rod, okay, and that's in my tongs. So if I was welding on the bottom of the screen here and I struck the arc right in this corner, I need a drag angle. Okay, I'm going to travel like this as I go across. I'm not going to push. I got to switch arms here. I'm not going to push that puddle with stick. That's not generally the way you would do it. So it's physically easier for a right-handed person to drag from left to right. Okay, so in that case, you're kind of seeing where you've been, not where you're going. But because the stick electrode is so skinny, it doesn't block your view. Now, as far as the electrodes are concerned, I'm running a 7018 electrode here. So if I can get the camera to focus right here. So this is a Bowler wire. It's 7018 H4R. So the H4 just references the hydrogen content in the wire. Hydrogen just basically the result of moisture. This is a low hydrogen electrode, so this actually has 4 milliliters of hydrogen, or 4 milligrams per liter. I forget exactly what that means, but something like that. And then the R means it has a moisture resistant coating. If you're buying 7018 electrodes to teach yourself how to weld at your local welding supply store or Tractor Supply or even your auto parts store, make sure when you open that can that you throw in some desiccant of some form, or ideally they'd be stored in an oven. That's not something the average homeowner is going to do, but you really do want to make sure these rods are kept in a room temperature, dry environment. Moisture really is a bad thing for 7018, and I would recommend, again, sealing that original can back up with some good tape, and throw in a little desiccant pack in there, and then before you operate with these electrodes, down the road, put them on a cookie sheet, throw them in your oven at 250 degrees for, several hours, and they'll run a lot smoother. All right, right now I've got a plate tacked up. This has actually been welded on the other side, so I'm not going to go through the process of tacking this on camera. But as far as the travel angles are concerned with a horizontal weld, and this is horizontal, okay, just for note, flat would be like this. If I tip this up, so in theory this could hold water like a trough, that would be a flat fillet weld. We're welding horizontal fillet weld here today. So the rod can't be laying down flat like this, and it also can't be straight up vertical. As a general rule, you want to bisect whatever angle that you're given with stick electrode. So if I have the rod in a 90-degree joint, I want the rod at 45 degrees. Now, the drag angle, again, I'm not going to push this except under unusual circumstances, which we won't get into today. But essentially what I want to do is I want to have that rod at a drag angle. I could go as little as 15 degrees and realistically as much as about 45 degrees and produce a quality weld. The reason you don't want to push is because the flux on the rod, the white flux, which creates the slag that holds the weld in place, the slag tends to get ahead of the puddle, and you're welding through it instead of welding on nice clean base material. So just like if you have a little puddle of water, in your yard and your driveway, you can take a garden hose, and by going back and forth with the hose, you can push that water out. The electromagnetic forces and the arc forces will tend to push the slag to the rear when the angle is backwards like this. As you square this rod up, it gets harder and harder for that to pull to the rear, and you'll see slag chase ahead of you. And I'll demonstrate that in the what not to do portion of this video. But recognize that while it may be difficult on the camera because of the angles, especially in the dark when I'm welding, that I am maintaining those rod angles, excuse me. I want to be halfway between the two plates vertically, and again I want to have a drag angle in here, and I will try to maintain roughly 30 degrees. I think honestly produces a good weld. If the rod is too straight, your weld will tend to be flat. If it's angled back too far, it'll tend to really be crowned up a lot, and you can inspect your work as you go and see if you're getting one of those two conditions. But as you're welding, you really want to make sure that you're keeping track of those angles. And when you're first learning, there's so much to keep track of that it's easy to forget that. So concentrate on those angles while you're welding. The other thing is the arc length. Now this is 70/18, this is a drag rod. I could literally drag this rod on the plate. Literally, just let it drag. I will tend to let the rod hover ever so lightly, and basically it's going to bump along. You want to make sure that the arc is tight, and when I push the rod in close, when it's welding correctly, you'll see the brightness of the rod will decrease, and if I pull this back it will increase, and I'll see the metal transferring across like a faucet dripping. And again, I'll show that live while we're welding. But essentially what you want is almost the effect that right at the tip of the rod is almost like a solar eclipse. And again, we'll take a look at that when we get started. So for right now, once you strike your arc, and again you can give it a little tap, make sure it's bouncing. You don't want to just go poke because the rod will just stick. But you either want to let it kind of a quick little bounce like you're tapping a snare drum, or you want to strike it like you're striking a match, okay? If you've used the rod and you stop, you may discover that the rod has a slag coating over the end of it. Now you can certainly pound on it and break that off and get it to strike an arc, but you're better off to do that, by removing it from the electrode holder and getting that bare steel end. You can also sometimes brush the end with your thumb and break that off, but don't try to strike the arc when it's covered in slag. All right, let's get set up and we'll actually strike an arc. done with the rod, you should burn it down to about the numbers that are printed on it. Get your money's worth out of it. We'll let that slag cool for a second, we'll chip it off. And it comes off a lot easier if you let it cool. So I have a first bead. I'm going to wire brush that up. If you take a look at the weld, what we have is a crown to that bead. If I want to decrease that crown, I could turn up my amperage, or I could change my travel angle a little bit. So I'm going to increase my amperage by 5 more amps. Right now I'm at 120, I'm going to go up to 125. I'm going to try to maintain the same angles, although again I'm still welding under the camera, so it's a little bit more of a challenge than I would like it to be. Extend my ventilation tube out a little further. So here we go, 5 more amps, we'll see the effect of this. Again, when I strike my arc, I might as well show this now. I'm going to attempt to strike the arc right here, and then come back. I come around the top, make a loop, and then swing back in. So you can see the shape of that weld puddle. It's kind of a teardrop shape, elongated, maybe like an almond shape. So again, I'll strike the arc at the tip of that, and then I'm going to come up around, loop in, and I'm going to try to blend it like that. The end of the electrode, the camera's on manual focus here, folks, so it's, I apologize. The end of the electrode, again, should be bare. And this is a new electrode, so it is. And again, we're going to try to maintain those same angles, and 5 more amps, and we'll see the effect of that in the puddle. So I had a little more rod left. I could have burned a little bit more, but my hand was up against the bench, so I'm going to stop. Again, allow it to cool, and lightly chip at that top. So let me clean this up. We have quite a difference in the flatness of the weld.
So pay close attention to the arc. The rod should be in close where it's almost touching the puddle.
Learning
and you can see that bright area around the arc that kind of resembles the sun peeking around the edge of the solar eclipse.
Is not necessarily correct. So
you don't want to see the transfer of metal
simply note that
from the rod across to
the amperage is generally pretty consistent.
If you do, you're either
on
going too
machines.
Fast or the weld's too far away.
This little machine I'm running today runs much like a larger Miller, a nice Miller machine, professional machine. But don't assume that that's the case. The puddle should flow fluid and should be very liquid. You should have control over it, but you shouldn't have what we call spatter. You can get a lot of spatter by running excessive amperage. So at the beginning you can see where the weld, it's a decent weld, I'm sure it's strong, I probably have fusion in the root of the weld, but I've got a little bit of a crown there. Now that crown can also be the result of too much travel angle. I'm trying to maintain the same angles, but again, I'm welding underneath the camera with everything in my way, so I may be off a little bit, but 5 more amps just really help to flatten that bead out, okay? Now what I'm going to do at the end of this plate is I'm going to turn this up another 5 amps, and we'll see if I get any spatter, okay? We'll see what the effect of that is. I should see a flatter weld. I suspect at the end I'll get some spatter from what we call magnetic arc blow, which is a topic for another day, but suffice it to say that the magnetic fields created by welding currents can be pretty strong, and those fields can have a tendency to push the weld where you don't want it to go, even to the point of causing small little eruptions that are like little volcanoes going off in front of you. And there's ways to get around that by changing your rod angle, reducing your amperage, changing your work lead or your ground location. I got a plate on a bench, so I don't have a lot of control over where the ground is, short of propping one end of this up on a piece of ceramic. But I'm just going to keep the angles the same, and we'll just see what happens when I get another 5 amps. So I'm at 130 amps right now, folks, which again, under certain circumstances is pretty nice for a stick, but I suspect it may cause some issues here at the end of the plate. And make sure I'm in focus, and here we go. Again, strike the arc at the tip, loop up around to blend it.
So if your weld bead has a sharp ridge down the center of it, it's usually an indication that your rod is at too much of a drag angle.
So I'm at high school, so you probably just heard the bell.
More amperage can eliminate that, but your best bet is to get your drag angle a little less severe. 25 to 30 degrees.
But not bad.
It's pretty good.
Again, I'm going to let that
Additionally,
cool.
if your weld bead, at least with 7018,
take a look
is
at
really
it. That's a little
flat,
more than I want. Now, what I'm going to do is I'm going to continue
too
welding
little
over this
drag
plate,
angle, or
progressively
you're
adding
too
more
long
and
of
more
an arc.
passes. And I want to get to the point where I have a little bit of excess heat. Now again, when that slag is soft, and I can see it here with my eyes, it's still a little bit reddish brown. It's hard to chip off, so let the slag cool, and it comes off a lot easier. Otherwise, it just gets soft under the chipping hammer, and it just kind of mashes it in like Play-Doh. Now you can see the way that the weld beads blended together at the restart. It's coming out pretty nicely. So I'm going to go through now and mark these restarts. The first restart being right here. The second restart, again, being right there. So that little trick of looping around and blending in, again, works pretty nicely. See if I can get this in a little bit better focus right here. Kind of have to put a line on the bench here to keep track of where my focal point is. All right. So again, what we have basically is a bead that's crowned up, which means that, we could have just a rod really laid back at a steep angle like so, but at a normal travel angle, 25 or 30 degree drag, if I'm getting that crown, I may want a little more amps. So we added 5 more. So this was, again, 120 at the beginning, 125 here in the middle. That's a nice bead. I want a little bit of a shape to it. I don't really want it flat. And we've got a little bit of a crown, smooth appearance. And then down here was 130, and the bead was a little harder to control. It wasn't excessively difficult, but it was a little harder. I'm going to go back to the very beginning, and I'm going to stick with that 130 amps until I have burned off the remaining part of that rod. And I have a little bit of point on my electrode here where the flux is sticking out past the tip. So I'm just going to tap that on my bench, or again, I can break it off with my fingertip perhaps, but I want to make sure that that bare electrode is exposed so I can strike an arc. There's not a lot of rod left, but we're gonna go ahead and burn it. Now this second pass for a multi-pass weld, and again I'm getting a bead that's progressively larger and larger because of the amperage, which we wouldn't normally do, but for demonstration purposes of tuning the machine in, I'm not going to lay the rod really down in this corner per se. What I'm trying to do is I'm trying to add a little bit of weld out on this bottom, what we call leg. So the height of the weld from the corner up and the height of the weld from the corner out is called the leg of the weld. What you see is the face. An imaginary line from the corner out through the center of the face is called the throat. So I'm trying to increase that leg length by approximately the rod diameter, you know, just as a ballpark. It's not a rule, it's just a, you know, general guide. I'm also trying to cover this original weld, and I'm not trying to cover all of it, but I'm not trying to cover just half of it. I'll probably cover about 70% of it with this next bead. And that'll get harder to do as we get near the end, and the amperage was higher and higher. But again, that's what I'm going to attempt to do, is just run this bead over the other one. And again, this is still at 130 amps. So the rod is not right in that corner resting, it's slightly above it. I'm extending the bottom leg, and I'm covering most of the previous pass. We have it right there. I'll burn one more electrode at 130 amps. So the 130 is actually running quite nicely down on this end. As I get closer to the end of the plate, I'll be more likely to experience arc blow. Right now it's running quite nicely. I've got a nice little bead right there. Again, I'm trying to extend the bottom leg by approximately the rod diameter, and you know, there it is, right? That's what I'm adding, and I'm covering most of this previous bead. It's actually almost completely covered, but to the height of the crown, it's about 70%. So I'm going to stick with 130. Again, it's a horizontal weld. I can get away with a lot because, you know, gravity is my friend here. Also, I'm using an S-wing chipping hammer. I'll try to get a long shot of this thing, but it's the best chipping hammer ever conceived by the hand of man, so you should definitely buy one. I'm not paid by anyone. This isn't even a monetized channel, but I'm telling you, once I got the first one, that's what I have at the school exclusively. I got rid of everything else. The S-wing chipping hammers are freaking awesome. But again, strike the arc. Gonna come back in through that loop, lay the rod down, and then I'm adding weld to the bottom edge of this pass. spatter down on the bottom edge. These little parts right here I'm sliding off, chipping hammer, or spatter balls. They're small at this point, so I can live with them. And again, I've got a decent bead profile. Plate's getting pretty hot. I'm going to use my pliers when I clean this off. So there is our continuation. Again, the restart is right here. We get a nice blend by doing that little trick. And that's not quick. If you notice that, I'm coming up in slowly and looping around. I'm not in any big rush, folks. So there's our horizontal weld as we continue. And again, I'm going to continue this last part by showing you some things not to do. Okay, so this last section is going to be a few things not to do. What we'll end up with is a multi-pass weld where the first, section of it, the first 2/3 of the plate looks good, and the rest of it looks like garbage. So the first thing I'm going to do is I'm just going to show you variations in arc length. Okay. I want to wait for the bell. What I want to do is I'm gonna push the rod in where it should be, and then I'm gonna pull it out too long. And I want you to pay close attention. You're gonna see the literal transfer of metal going across the tip of the rod when the arc is too long. That will crush you on verticals, okay? And on overhead, you'll wish you weren't anywhere near the molten liquid that's over your head. So you want to break that habit in a flat or horizontal position. So I'll start off correct, and then I will transition into too long an arc, and then I'll push it back into the correct arc length, and I'll go back and forth. Again, you can get away with a little bit of too long of an arc in the downhand positions, but you won't get away with it anyplace else. So break that habit now. Now here we go. Strike the arc correctly. A little bit of a hesitation there. Alright. I want you to look carefully at the tip of the rod. We have a bright little ring around the darkness of the rod. And I'm going to pull the rod back too long. That is too long of an arc. That's way too long of an arc. Back incorrect. It almost looks like a solar eclipse, like the moon blocking the sun right at the tip of the rod. Too long. Correct. Too long. Correct. Too long.
So while we're welding this,
Correct.
take a look at the arc and take a look at the puddle, the back edge of the puddle
So
on
when
the
that
bottom.
arc is at its correct length,
You can see the slag.
I can feel the
it's
rod
thicker.
touching the plate.
So
may
it
not
kind of shows
necessarily
up
feel it
in the
100% of the
camera. It's
time.
darker in
It
color.
depends on where
But
you
you should
are
really
in
be
your
looking
weld
at
process.
that oval shape, that
verticals,
liquid.
you won't necessarily feel
while
it
you're welding.
unless you're weaving a little left and right. Overhead, you may not feel it at all. But you should occasionally feel it bumping your plate when it's at its correct arc length. Now, just because I held that way too long does not necessarily mean that I have a bad weld. It certainly increases the likelihood that I'm going to have porosity or small inclusions of what basically amounts to nitrogen gas inside the weld. But you can get away with it on the downhand position to some degree. It will most definitely mean that the weld is not as pretty as it was before. Okay, but it's probably still serviceable. That will not be the case in the overhead position. You will make a ginormous mess, okay, in the overhead position. Vertical is you will burn holes through the plate. So we're going to go back to the beginning. Again, focusing on correct arc length, and we're going to finish off this multi-pass weld. Now you could put 3 passes over this and 4 passes over those 3 and so on and so forth. But for the video, I'm just going to go so far as 2 cover passes. So here we go, correct arc length. Now what I'm watching here is I'm going to try to watch the rod itself. I'm not plugged into the electrode holder right now. I want to watch that rod rest in here, and I want to watch the bead blend between this ridge, this high point on this face, right, the top of that crown, and I need to add that extra 1/8 inch of weld to the top leg so that the weld stays the same size from the center out and from the center up. Now again, I'm bisecting the angle that I'm presented, and I forgot to mention that on the pass, but essentially, you know, the angle that I'm putting the rod is based on what is already there. So I'm going to back this up just a whisker. I'm going to put this plate down, and I'm going to put my piece of soapstone in to simulate a weld bead. Okay, let me turn this around. This is the ginormous weld. Once I go ahead and put my rod in on that first pass, I have a 45-degree angle. I got to hold this with one hand. I should take my gloves off, but I should do. So I have a 45-degree. I'm not way down low. I'm not way up high, right? I know my hand is blocking this. I apologize. I'm halfway between. I'm at a 45-degree angle. Once I get to where the other weld was, if this was the face of my other weld, right, this soapstone, this angle here is not 90 degrees. I have 90-degree angle here, right, but I do not have a 90-degree angle here. I have roughly 135-degree angle, so that means that my rod is going to have to go up a little higher. Okay, that rod will not be at the same position it is. Everything's in the way here, folks. The camera, everything's in the way. So you always have to look at the angle that you're presented, and you want to bisect that. So here, I'm looking at the angle that is between this bead and the plate. And again, I'm approximating the middle of that angle. So here we go again. And this is the long part of the video. We'll speed this up as we get into other positions. Again, I'm watching the puddle blending on the bottom and on the plate. I want to let that liquid go out to the center of the face of the previous weld. I want to keep that rod in close. I can feel it touching. It's very light, but I can feel it. I'm bumping the plate from time to time. I'm bumping it more than normal because, again, I'm off to the side welding under the camera, but you should feel it on occasion. And I've kind of got my hands jammed up on the bench here, so I'm going to have to stop. We'll stop right there. I'm almost off camera anyway. So that would be the correct travel speed and angles. Now the travel speed is something that you're going to judge by eye. Okay, you are going to assess your travel speed based on how much weld you need to put down. If you need a little weld, you're going to travel relatively fast. If you need a large weld, you're going to travel somewhat slower. In this case, we're just trying to blend the bead into the previous pass and also add some weld up on top. So there is the multi-pass weld that I've placed down. Okay. So that is what it should look like, more or less. Again, it'd be a little easier if the camera wasn't in the way, but you know, I'm not gonna say that weld isn't a pretty decent little bead. All right, now the rest of this plate, what I want to do is I want to demonstrate a few other things that are wrong. And I'll try to do this as I go. The first thing I'm going to do is I'm simply going to travel too fast, okay? So I'm gonna go too quick, and I'm gonna have the weld not blend in correctly. Then I'm gonna actually pull the weld out too far onto the lower plate. Then I'll go up too far onto the upper plate. Then I'm gonna slow down and travel way too slow. I'll try to do that all with this one rod. So here we go. Too fast to travel speed. So I'm not bridging those two welds together. Now, if you're not careful, you might find that your weld all of a sudden is out on the bottom plate or the bottom weld a little too far. I could also find that I'm up too far, and I'm not in the groove like I am now. I'm up above the puddle. And then finally, I could just be traveling way too slow. And what happens when I travel too slow is that the slag is going ahead of me. So let's look at the effect of that. And these are some things that you may see when you're first welding. It's really important that you can see where you're going. It's important that you have the right shade on your lens. If it's too bright or too dark, you will not have the ability to see what you're doing. So again, if I weld too fast, like I have right here, I haven't really fully blended that weld in. It doesn't look horrible from this camera view, but again, it's not as full as the other weld. Then I let the rod get away from the plate, so now I have left a gap in here. I've actually trapped some slag up in this corner, which is going to be hard to get out. Really hard to get out. Then I went up very high on the plate, and again, it's not going to blend correctly, and then I simply traveled too slow at the end. So that's the effect that would have on a multi-pass weld. Now, let's look at those same effects on a brand new plate. Again, these are what not to do. So I'm going to do the same thing in a corner, and I'm going to put a soapstone mark down so I don't go off camera. So here we are. So the furthest down I can see is roughly right here. So I'm going to travel too fast. I'm going to attempt to do one thing wrong at a time. A lot of times people travel too fast and have too long of an arc. Looks like I've got something stuck to my plate there. All right, so here we go. Too fast. Yeah, it's funny, I was just thinking the next thing I should do is what to do when the rod doesn't start or when it sticks. So what's happening is I'm not completely filling in the path that the arc is giving. I'll stop right there. So when the weld is too fast, the slag covering is thin, and you'll find it's going to be difficult to remove. You'll also discover that you could end up with what we call undercut. which is an area along the edge of the weld, the toe of the weld. Okay, so welds have legs, which is the distance from the corner out to the outermost edge of the weld. The outermost edge of the weld is called the toe. Okay, so I have a very small weld. Now that weld may be serviceable under certain conditions by traveling what I would call too fast, provided you also don't have too fast and too long an arc, which is what I'm going to do next. So this will be too fast and too long an arc. And again, I can weld to about, I'm just going to go right to about here. So too fast coming up and too long of an arc. I can see the metal transferring across, dripping. I can see the arc digging. And I think I just saw some porosity. So remember, we're not trying to spray weld across the stick electrode. We're trying to transfer that metal very, very smoothly. It's like taking a pitcher of lemonade and pouring it into a glass with the pitcher held way down low, so the water, the lemonade just goes in very, very smoothly without falling from any height, making a splash. So as I've held my arc too long, one of the effects is that my bead is flat. Okay, the bead is very, very flat, and I've actually got holes in the weld. You can see, if you look carefully, I'll try to point these out. Right in through here, that's actually a hole in the weld. That's not a dimple from the slag hammer. And I have some small holes right in here that are hard to see, get the light just right. Okay, so those holes are porosity. And the reason I have porosity is because I don't have any shielding gas protecting the weld. There you can see it quite clearly with the flashlight. Okay. I also have a lot of spatter. All these little balls are hanging out, stuck to the plate, are called spatter. And I have undercut, which is unfilled areas at the toe of the weld, and that's what makes it difficult for me to remove the slag. So traveling too fast or traveling with too long of an arc, or both, is almost the worst case scenario, will cause a lot of problems with your bead. Okay, so just simply traveling too quick, we just have a small weld. If I keep the arc really, really tight, I can travel very fast. But again, the problem usually is that the arc is a little bit too long. Now we're still at 130 amps, I just want to know, okay? So I'm going to take the rest of this rod and I'm going to keep the arc very, very tight, and I'm going to travel very, very quick, and I'm going to put down the smallest weld I think I can put down without changing any of my parameters. So again, if the rod is kept tight, the arc real short, and the travel speed is fast, you can actually be okay. I should also note that I'm not dragging it as much. I'm almost a 90-degree push angle. So I'm almost forcing the rod into the plate. I can feel the rod touching fairly aggressively. So I've gone ahead and I've eliminated my drag angle. I've gone to 90 degrees to a slight push perhaps. And I've really made that arc as short as I can make it by pushing the rod in tight. Okay? And the result is I've got a nice little bead here. So again, too fast to travel is relative, okay? It's like saying you're driving too fast. Well, when you say you're driving too fast, there's no specific speed limit associated with that statement. It's for the current conditions or for the area where you are. So again, if I maintain a normal arc length and travel quick. I get a bead that is rough, and I have spatter, and I have undercut. I have unfilled areas. You can see this little hollow right where the brightness of the light is, with a slag trapped in there. There's a shadow being cast. That's undercut. If I travel, again, a little too fast with the arc too long, well, if the arc lengthened, I'm really forced to slow down, because the arc, as it gets longer, it gets wider and it digs a larger hole, and the rod has to fill that hole in. In this case, the arc was so long that I actually lost gas coverage. That flux does create a gas that shields the weld from the atmosphere. That keeps nitrogen from getting into the weld. If you look up the bends on divers and read a little bit about the bends, you'll understand that. It's the same basic process that causes porosity in welds. And then at the end, I said, I'm gonna travel just as fast as I did at the beginning, but I'm gonna put the arc excessively tight. So again, by keeping that arc really, really tight, I eliminated the undercut. It's gone. Now, is there still a little bit of spatter? Sure, but watch this. So that spatter was relatively lightly bonded. A lot of that small stuff just came off. And at the very end of the plate, again, we're dealing with what we call magnetic arc blow, but you can put down a very small weld if you keep the arc short. So there's a relationship between travel speed and arc length. All right, the last basic error that I will discuss with stick electrode is not keeping the rod in the corner. That rod needs to stay pointed towards the corner. Now in this case, it's the literal corner of the two plates, but it could be the corner of a previous pass in a plate, or a previous pass in another pass. I can't have the rod out here as I'm welding, nor can I have it up above the corner, okay? It's got to be right in the corner, not up above, not out here. And that's a common thing that'll happen. This rod is getting shorter all the time, so my hand is feeding in at a really, 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 really slow pace, constantly. I'm used to that because I've been doing this for 33 years. But again, when you're first starting off, you won't be, so you have to consciously make sure that you're feeding in. Failing to feed in will oftentimes cause a long arc, but it can also cause you to travel out. So again, I'm going to start correct. I'm going to mark the end of the plate so I don't go off camera. I can see all the way to here. Okay. And then I'm going to travel out on the bottom plate, and then I'm going to go up on the top plate. We'll take a look. So right there, I'm right in the corner, lightly dragging. Now I'm going to forget, I'm going to come out. I see students do this all the time. What will happen is I will get to the point where I will get slag stuck in between this bead and the corner of the plate. Okay? Then I'm going to go back into the corner for a second, and then I'm going to come up. So getting above it is usually worse because there's no support for the bottom of the bead, and it tends to really make a big mess. The last second, I'm going to go back down in where I belong. I will note that I maintained a reasonably proper arc length throughout that exercise. If you were to combine getting out on the lower plate or getting up on the upper plate with too long of an arc, you're going to have a hellish mess. Really, really bad. So really keep an eye on the location of that weld bead and make sure that you're staying in the corner. Okay. All right. So that's the basics for welding in the horizontal position. Now welding in the flat position, again, flat would be as if you're literally welding so that the joint can hold water. I would have to tip this up, you know, like so, to be in the flat position. You know, so this is horizontal, looking at it from behind, and then flat would be literally like so. Let me zoom out. There we go. So again, horizontal weld right here, and again, flat would be tipped up, you know, something like this. Okay. So this will not affect those techniques very much. On the rest of this plate, I'm simply going to run a few beads and just kind of demonstrate some general technique. For making the weld bead a little bit larger. So again, I can start off with a really small weld. And then I can make that weld a little bit bigger with a slight little weave. I want to just caution on weaving. You want to avoid weaving any more than absolutely necessary. Lay the rod in and you know, do that, but avoid this manipulation, whipping, moving, circles. You know, you can get away with that with MIG welding. You can get away with that with certain stick electrodes, 6011 being one of them, but it's not something you want to do with 7018, okay? So again, I'll show you the maximum that I would ever manipulate the puddle really with a 7018 electrode here. And again, this is in the horizontal position. In the true flat position, you could get away with a little bit more. So I am consciously moving that rod up and down. I got my elbow caught on the table here. Now, I'm going to go a little excessive here. And I want to show you why it's excessive. I've got slag ahead of my puddle right now. That's always a dangerous thing. So anytime you get to the point where the slag is starting to get ahead of your puddle, you are weaving too much. You want to make sure that you're keeping that slag in check and behind you. The slag will get in the root of the weld in the corner, and it will prevent you from penetrating into the corner. And again, you can check out the video on fillet break tests and get an idea for what I mean by that. Okay, but I've actually got a hollow spot at the tip of this. I'll get my flashlight. And I can see where the weld is not. Let me brush this off. I can see where that weld is actually not in the corner. It's actually bridged across the corner a little bit. Okay. You really want to avoid that. You want that weld to melt all the way into the corner. So you've got to be very careful if you start doing any weaving on a flat or horizontal. And in general, you need to be aware of what you're welding. Some materials just cannot get excessively hot, and weaving accomplishes exactly that. It makes the material a lot harder than it needs to be. Although for, most steel, mild steel, that you would ever practice on in the school, that's not realistically going to be a problem. So again, that's horizontal welding with stick and some of the basic things that you could in fact do wrong.